Welcome to 3.4, page 6, one of our longer sections. It's just one that I feel like we need a lot of practice on compared based on previous year's results, and since I've gone to a lot of practice, we've gotten a lot better at these. Okay, so here I've got plain old ln, I like that being all alone, equals 1.5, and this is a definition of log problem. If I can get plain old ln equals, or plain logarithm equals a number, definition log. So this is the exponent that turns e into 2x, but this is 1.5. So 1.5 is the exponent that turns e into 2x. This is the exponent. We know that. This is the exponent that turns e into 2x. Can we apply it? Well, this is 1.5. So 1.5 is the exponent that turns e into 2x. And at that stage, exact answer, x equals e to the 1.5 on 2. And you can check that with your calculator. You do not have to. You've got answer guides, but you should be able to check it on your calculator. If you need to see an example of that, I did that on the prior problem for you. All right, I did that on the earlier video on 3.4, page 5. I did that on, I didn't show it here, but I did that as part of the video. So if you need to go back and review that, great. So there's our exact answer. I want round to 3 decimal places. So second e to the 1.5, step out of there, divided by 2, approximately 2.241. Okay, now these are my favorite kind right here. If you've got log of equals log of and the bases match, you can drop the logs, and that's because logarithms are 1 to 1. So if I got log equals log, logs on both sides, don't bring them to one side and smash them together or anything like that. Just go, hey, take advantage of it. This plain old log equals plain old log, we can drop them. And we get 4 plus x equals 2x. Now there is a little caveat to that when we drop the log, and perhaps it's going to happen right here. We'll see. I get 4 equals subtract x. Oh, it's just x equals 4 is our answer. Now, you do not have an option. You have to check this. Can I put 4 here, and can I put 4 here? In fact, we probably should start off by saying, hey, what's our domain here? In this case, x has to be at least, or excuse me, has to be bigger than -4. In this case, x has to be bigger than 0. So if I would have solved this and come up with an answer, x equals -2, -2 would be fine here, but -2 causes problems here. I can't have a logarithm of a negative value or 0. So checking solutions that way for domain errors, probably a pretty good idea. For instance, in 100, x better be bigger than 0. Okay, so let's see. ln x, we're going to get it alone. It was 10. I subtract away 3 before I divide away 2. ln x equals 7/2. And now, definition log. This is the exponent that turns e into x, but this is 7/2. Therefore, 7/2 is the exponent that turns e into x. That's understanding definition of log, not just spouting it out. So we get e to the second ln, e to the 7 divided by 2, approximately 33.115. Okay, now I want to distinguish here, once we got to this point right here, this was the definition of log. This is not definition log yet. I need to get rid of that 4. The first thing I want to read is log. So this is log 10 x minus 6 equals divide 4 11/4. Now, definition log. This big old thing here is the exponent that turns 10 into x minus 6. Can we apply it though? This is 11/4. So 11/4 is the exponent that turns 10 into x minus 6. Or x is 10 to the 11/4. Rescue the 6 with addition. 10 to the 11/4 plus 6 is approximately 568.341. Okay. This is definition log right now. Oh, by the way, my answer was bigger than 0. Oh, by the way, 568, this one, x has to be at least 6, so that answer is okay. I probably should be more faithful to checking those, because I do suspect we may get a problem here. Now, we're at definition log time. Plain old log equals a number. So this is the exponent that turns 12 into x squared, but this is 6. So 6 is the exponent that turns 12 into x squared. So let's see, 12 raised to the 6th is, so x squared equals 2985984. Algebraically, when we take the square root, we need to do plus or minus. X equals plus or minus second square root, second answer. And I get 1728. Now, can I put positive 1728 in here? Yes. Can I put negative 1728 in here? As it so turns out, yes. So we actually get both these solutions. I was thinking maybe we'd have a solution that we were going to cancel, but we don't. This is just asking what is 12 to the 6th, the square root of that. So we do get two solutions, and you can see that your problems model my problems very, very closely. And that video was 7.5 minutes. Don't hesitate to ask questions, as always.